all the way from Belgium. He can tell us more about himself if you wish.
Yeah, so I am Julien. I am a person consultant at Inuit. I have been using Puppet since 4 years now, and I am involved in the Puppet community. I contributed to the core and to some of the modules. You can find me on Twitter, IRC, and GitHub under the nickname Roi de l'Appli. So I work at Inuit. We are an open source company in Belgium. We do we do consultancy like system administration, development, and a bunch of stuff. And automation is really a big part of our business, actually. So, and we do a lot of that with Puppet. So nowadays, when you look at the IT world, it is more a world of where you pay for a service, and then you don't buy a software anymore. In a lot of different cases, you are just even you are setting up the service by yourself, or you are just paying to get something in the cloud, or that you can just use at will. But this is only true for the real IT industry. I mean, in the other industries that are using IT, it's not yet the case, like in the telecom industry, where you still pay to get the software that you will run by yourself. So when you are providing a service, it's really easy because you know the environment, because it's hosted at your site. You know how to do the maintenance. You know how to upgrade the software and when you need to do it, because everything is in your hands. But when you are shipping softwares, it's really a different way of working because you don't know the environment it will run on it. You can always ask for a specific environment, but there is always be limitation, or customers will set up a different thing, and you don't know how the application was set up because, yeah, it's not you that sets it up. It's often 2 or 3 layers of people that will just implement what you have done. You don't know if the customer have changed something, so if they have change the Apache configuration, or if they have tuned the MySQL configuration. Some of them might also try to change your wrapper scripts and stuff like that. And you don't know if there will be someone that will be able to maintain that software, or if the software will be monitored. It means that it's very 2 different worlds. In one world, you know that you will do everything, and the other world, you know that someone else will do everything for you, but you don't know in which context they will do it. You know your own environment, but if you ship a software to a customer, there is a lot of chances that that environment will be fixed. So you will see, I need that environment, and it will be the same for the next 5 years. There will be no evolution. When you manage everything by yourself, it's easy to do rolling updates, so you can easily add features and stuff like that. But when you ship a software to a different company, then you will need to do more planned updates. Like, you will not be able to say, tomorrow we'll update the Apache version of your environment, or we'll add that feature, because it's not easy to get access to those environments. And also you need to plan it, and to also to the commercial to use a commercial flow to just say we'll make an update. And often in your environment you will have a nice monitoring system, but when it's as customers, then you will just have the end user that will say, oh, it's not working, because it was not implemented into their own monitoring system, because actually they think that they have just bought a black box and that it will just work. So when you ship a software, you expect it that it will be self-hosted at the customer, but it will still be a complex software. It will just not be one binary that will run one daemon. So you will have multiple components like Apache, MySQL, your application, maybe ActiveMQ, and you will have a lot of different software that you will need to manage to set up so that they will be able to work together. You will also need to be able to scale it, so you will need to know upfront how many nodes will I need, what will be the configuration of my MySQL setup. And that will bring you a lot of different things to think before you will ship your application, because you know that once it will be set up, each change will cost a lot of money. So you will set a big list of requirements, like I want that operating system, I want that many CPU, that many memory. And also, you will have a lot of dependency. And by dependency, I mean Apache, ActiveMQ, and you will need to ship those dependencies as well, or to ship the way to configure them. So what happens when you ship a software, when you distribute it? Usually, you have the software, a user guide, and an installation guide. In the big enterprises, you also have people that will install that software. But there are a bunch of challenges that you need to think about, like the artifacts. How will you ship your software? What will be the final form? How will I configure that? And how many components will I need to configure? You need to think about the security. How can I improve the security on the operating system, on the application, on the different network layers? What will be the hardware requirements? What can I ask to my customers? What will they be able to do for that? The software requirements, it means that I want that operating system at that specific version, or at least that one. But you will need to know that upfront, because even if you can be quite flexible with that, you will still need to probably stick with one operating system family. There is also the challenges of the upgrades, which takes a lot of time, a lot of paperwork often, that you don't have when you run the operations. For example, if you have a bug like a glibc bug, or if you have a bug like Heartbleed, then you need to have a procedure that allows you to correct these bugs quite quickly. But in most of the cases, it's quite complicated, and some customers will say, "Oh, yes, but we are not internet facing, so it's not that a problem." But nowadays, it's a problem. Each private network tends to become public, because you need to have more and more security concerns. And the last part is the monitoring, which is a big challenge into software shipping. A lot of products will, for example, ship with a monitoring solution, but it will never send any mail. It will never want anyone, and it will only collect data, and then you will just be able to collect this data when there is a crash or something like that. But often there is no mails that coming out of that monitoring system, and it might even be hidden into the product itself. So the first challenge is the artifacts. So how do people distribute software? You can distribute it using FTP. So just I will put that on your FTP server, which is really bad for a lot of reasons. Some of them are using also SCM, so that there is quite of a version control. You can ship a tarball, but then how do I compile it, or what should I do? Then you have a self-extracting tarball, so you have a shell script that will extract a lot of data and then run some different stuff, like the configuration and stuff like that. But it is still a shell script, so it's quite fragile. We have software that ships with curl pipe bash, which is really bad because you need to first read what is on that specific script. You have products that say, okay, here is the Docker image, but this will not tell you what is inside that Docker image. How did you make that Docker image? How can I modify what's inside? And then you have the packages. So my preferred way to make artifacts are the packages, because you have a lot of built-in features with the system packages. A lot of people will tell you that it's complicated to get a nice package, and that's true. If you really want to comply with the application requirements, the operating system requirements regarding packaging, it's quite complicated. But what you get at the end is that you have a consistency check of the file. You can see if files have been changed. There are some customers that will just take your application and try to modify the jar files, and then if you ship them with a tarball, you will not be able to see the differences easily. So that's the first point. Then package gyms allow you to have dependencies, like I want my application A at the same version as my application B, or I want my application B to require a MySQL server. You have repository, which means that you can put updates into a safe place, protected using HTTPS or HTTP basic authentication, or even SSL certificates. And you can do that, so you can always do a Yum update on the customer side, or do it with Puppet maybe, to just do updates from a central point. You have GPG signing, which is also important. If you want to GPG sign a tarball, you can also, but then how many people will actually check that the signature is correct? You have a big tool chain with the packaging. Like if I want to get an information for a package, there is the RPM command, there is the dpkg command. You have tools to see the dependency. You can really do a lot with packaging that if you have a tarball, if you have anything like that, it's a bit more complicated. You have a clear versioning system. So there are lots of applications that I've seen in the wild. So it's a tarball or it's something like that. The first thing you need to do when you update is to remove the original application, and you just let the data. But then what does it mean then? It means that you do not know which version there was before, you do not know which version you install. So it's not clear. And with packaging, you have that versioning information that you can just do a Yum update, and it will just change the needed files and remove the files that are not important. A package is a unique artifact, and normally you have a source package that allow you to just rebuild it in a quite easy way. You just need the same source and stuff like that. And what's nice with that is that you don't only want to automate the deployment of your application, but you also want to be able to rebuild it at any time with the new parameters that will need to be set it up, because for some customers you will need to do some emergency patches, and so that you might want to say, okay, I need that application version -5 because that's what that customer is running, but with only that modification. And so if you have a nice package application, it's easy to take the source RPM and to change something inside it. And the last point is that the configuration management tools, we know that very well. So Puppet and Chef, you can just say, I want that application at that version, that package. And if you have any other kind of installations, it will just not work with Puppet and Chef, because you can always say, please Puppet execute that tar command, please Puppet launch that installer. But if the installer is not unattended, or if for some reason the installer installs each time that itself, it will just not work. So that configuration management integration is really important nowadays. And a lot of tools that do not comply with configuration management because they install with a script that asks questions and stuff like that, a lot of the times they will just be abandoned, and you will just switch to another software to do the same stuff. So you will ship with dependencies. Well, it depends if you really need dependencies, because you should limit the number of dependencies, because each dependency is a lot of work. The first advice I would give you is to just take dependencies that are also packaged. And then you should first take the package that comes from the distribution. Like if Red Hat is shipping a MariaDB package, then you should use that one, unless you need a higher version of MariaDB. If the upstream is shipping a package, it's also fine if you think that they will just maintain that during the lifetime of your application. The example of MariaDB, they also provide their own software or RPMs for Red Hat, for example. Then you can also use these ones. But you should try to avoid to go to third-party repositories, maybe except EPEL, because then you might get some troubles, because people will suddenly stop maintaining that repository, or they will just not build the latest version of your package, or they will apply strange patches on it. So for that, you should use distribution or upstream packages. And if you are using a repository like EPL, you should actually mirror EPL internally so you can rebuild a new host each time you need it. And you should also only pick the packages that you are interested in. And you should not expose your whole application in your host to EPL, because if EPL has a newer version of a package that you have packaged yourself of that upstream has made, because it's really a further version or for any other reason, then you will be screwed up. So you need to be able to say, I want to use EPL, and preferably you should be able to say, each day I make a snapshot of EPL, and I can use the snapshot from the day before if I need it, if there is a bug, if there is a problem. And when you will ship at customers your application, you should say, I have tested again that version of my repository, and I know that this will just work. And then you can update your repository just like your software. Like, there is a new version of my packages in EPL. I will first test it before pushing it to production, just like my software. And then we are coming to automation. So automation is really today the big thing in IT. Well, there is other big things, but it's really one of the main stuff. It's a new mindset for like 5 years now, so it's nothing new. But what do you want to automate? Because in this case, we want to automate from the operating system to the application, and every stack we want to automate it. We want to be able to reproduce our builds, like I've spoken, and also to manage our repository so that at any time I can build my Red Hat, my CentOS, my anything box, and I know that I will be able to set up my application on top of that box. So you need to think out the way you are actually deploying your systems. But that means also cultural changes. Like, you cannot do manual work anymore on the server because it will just corrupt everything. You need to use an appropriate tool chain, so Bash is not an automation framework. And each manual action, each time that someone will log into a machine and do something, you will have a lot of risk and a lot of cost. So you need to think, is that really needed, and how much will it cost? If you ship your application at 100 customers, then each manual action, you can imagine how much that will cost. And then when you do the update, you will think, what did I change 2 years ago on that software, on that machine? It did work, and then, oh, I forgot to back up that specific configuration file about the user's limit, and now I'm completely screwed up. So everything should be automated. It also means that you will also lower the installation guides, because the problem now is that you have a guide that will do the installation guide. Okay, it's fine, but he will not know exactly what has changed in the application, because his job is just to write the documentation. There might be mistakes because people never read this installation guide. They just look at the commands that needs to be run, and they will just apply them. So you will reduce the size of your installation guide, and instead you will give a bit of a Puppet training. But it will be valid for several products. So if you are shipping 2 different applications and you are shipping them both with Puppet, then it will just work as well. And you can also, if you really want, you have Puppet catalogs, which are the list of the resources that will be applied to a host. You can also see what is in these catalogs if you really want to have a list of installation of required directories and stuff like that. It is also possible to look into that, to reverse engineer that catalog and to make a bit of an installation guide out of that if you really want it. But let's go with Puppet. So Puppet, you probably all know that it is really widely used by a lot of different companies in a lot of different businesses. It is mature. It is now more than 7 years old. It is working in a client-server mode or in a standalone mode, which I call Masterless mode. And it is declarative. So it is a lot easier to maintain a code base that is declarative, because then you can make the things evolve without touching your declaration. So if you want to install the packages in another operating system, then you will not need to rewrite again your package's definition, no, because Puppet will know how to install a package or Debian and on CentOS. And it's really more readable also to have just that list of resources that you will need to have in your application. And Puppet here is scales. You have many ways to scale Puppet, so it's not a problem as well. But what do you want to automate? You can automate everything from the operating system to the application. In this case, I will not cover the platform because you will often expect the customer to provide the platform, so the hardware or the virtual machines, or so that's the expectation that you want for your customers. And then you can you will have customers that say, okay, but I don't want you to set up the NFS servers because I will come with my own solution, or I don't want you to touch the endpoints because I have my own NAS. And so for each part of your the thing that you are puppetizing in the previous slide, you should be able to just disable that. Like, I don't want to set up the Apache server because the customer will set one for me, and it will take care of the SSL certificates and stuff like that. So you should just be able to disable each of these parts, because as customers, you will not be allowed to listen on port 80 or stuff like that, or they will want their own hardware reverse proxy on top of that. So you should just be able to disable each part of what you are puppetizing. So you will use different meta modules that will call the real module. So it means that you will have a meta module for the reverse proxy, one for the repositories, and one for your application, for example. And you should just be able to disable them. But actually, you have three choices. It's yes, no, or noop. So you can include or not include a class, like I will include my OS tuning class, but you can also say I will not include it, but I will use Puppet to check if it was actually made by the customer. And that's the noop parameter that you can apply to the command line. So if you do a Puppet agent -- test -- noop, then Puppet should not change anything on the system. But you can also use that noop stuff only on one class or just one resource, which is extremely useful if you want to do a sanity check and check, okay, that directory should exist. The customer has told me that he would create it. I will just use Puppet with the noop, the resource with the noop option to ensure that this will be exactly the way I want it. So that's the use case for the noop option in one class. Puppet works with modules, which are some code that is used that will contain the different resources. So you will first think about using external modules, like I want to set up a MySQL. Why do I need to set up a MySQL server? Well, you will need to pick the best MySQL module that is possible. So the first way to look at is the Puppet Labs modules, because they are actively maintained and they have often a lot of community behind them. So Puppet Labs is always the preferred choice. Then you will look, okay, but MySQL, maybe they do provide a Puppet module like the Ikinga project is doing, so they are just providing Ikinga and the Puppet rules to use Ikinga. If there is none of the first ones, then you can look into GitHub and, okay, what is a good Ikinga Puppet module on GitHub, for example, or on the Puppet Forge. And each time you need to ask yourself, how tested is that module and how documented is it? And you also need to be sure that the module will just fit what you want to do. If you want MySQL with high availability, does that MySQL module support to configure the InnoDB logs and stuff like that? So when you include a module, you need to review it. That means you need to read the code that is inside. Because in your application, you don't want to give to customers a crappy code. So you will need to do the same with your Puppet code, because you don't want a Puppet code to do a wget, because your application will be installed in an environment without internet. So you need to be careful with the code that you implement into your application, into your Puppet tree. When you modify an external module, it's also important to contribute back. So if you have add an option to the MySQL module, just say, okay, I've modified that module. Please review my changes and implement them. So in the future, you will not have to patch the module. You will just be able to use it as it is on the Puppet Forge, for example. It also forces you to write tests, because if you implement a new feature, then it will need tests. And if you do it by yourself, you just say, okay, I don't mind the test, it's just 2 lines. But still, it's important for a long-term perspective. So it's important that you force you to contribute back. So you will be forced to write tests and to get feedback about the code you have written. And Puppet is not your core business. It means that you are not making money because you have improved the MySQL module. So why would you keep that secret? Just share with the community. So then you will need the modules for your application. But who should have access to these modules? Well, to me it's easy. Everyone should have write access and should be able to modify the code to try to understand how it works. You should try to make them the more clearer possible, so follow the Puppet style guide, because yeah, in Puppet you can do a lot of stuff, good like bad stuff. You can just do only exec in one file and it will just be a costly shell script. So you need to follow the automation standards, and you need to be ready for the future, because yeah, if your code is there for like 2 or 3 years, you know that the Puppet API might change during that time, so you might want to be ready for the future. And then you need to separate the code and the data. So that's the project Yara. Probably a lot of you have heard of it. I will come back to that later. But what is important is that you should not have data into your modules. It means that you should not touch your modules at customers. You should just be able to change the Yara data. So you will have a Puppet tree which will contain all the modules and the manifests. And then you have the submodules in your main repository. And you should give them the same version number. I mean, the Puppet tree and the application should have the same version number. And the parameters should match your product parameters. So you should develop your modules at the same time as your application. So if your application changes, you just have the corresponding Puppet tree so you can deploy the two at the same time. Then you can distribute your tree. What I recommend is to just make a RPM with all the packages, one RPM, so it's easy. And then you can use the package dependency to say, okay, I require Puppet or I require anything. And then you can add a helper script for the first one, so that when you set up the Puppet master if you want, then you just have one script to run. So Yara brings you data separation. Your classes should have a stable API. So if the MySQL classes change a parameter, then your main class should not change. So it's more easy. You should just deal with the API of the MySQL module into your own module. And you can use functions with Yara, like I want to deep merge that configuration file with that one, or I want to create the resources on the fly. That's a lot of functions that are really helpful in Puppet and that help you to work with Yara in a more clean way. Because yeah, you should think that your code should be flexible enough so that you only need to change the Yara parameters, which is a bunch of YAML file that contains data. This is the only thing that should differ between your customers. So in Puppet tree, you have automatic parameter lookup, which means that when you have a class, you can just put in Yara, like, I want that parameter for that class to be like this. But you should avoid that. That's my opinion, because you don't know where that parameter comes from at the end. You need to review all the Yara trees. So if you want to understand something that's broken, this is not helping you. But if you have an edge case, like for that specific customer, I want to have that stuff, then it's still nice to be able to use that and to say, I want that specific Apache parameter to be like that at that customer. So for edge cases, it's still best to have that be instead of changing the Puppet tree. Okay, now when you are going live, you have two different options. You can have a Puppet agent or a masterless. So which means that even you will pull a catalog from a server, or you will apply it from files. So we'll see the advantages of each of them. So the masterless run means that on each node you will need to have the data, so the Jira tree. It's a bit complicated because then you might have a different Jira file in 2 different hosts. So it's not really nice. Well, and it means that you lost the single source of truth that is really cool in Puppet. But you don't need a daemon, you don't need a Puppet master, you don't have exported resources, I will come a bit with that later, and you don't need Puppet DB, which I will also explain. So you have the agent mode. So it will, for example, when every 30 minutes it will pull its catalog and it will just apply it. It is really useful because then you will know if something has changed. If someone has tried to change the Apache configuration, you will notice it directly into that agent mode stuff. So on the long time, it can also help you to detect intrusions, and maybe if someone updates Apache and it changes the configuration, you will also notice it, so it's quite important. We have also Puppet DB. It requires a master, but it will collect the reports and it will store the different facts. So you will have something to query to see what is the status of my cluster. Are all my all my nodes are playing their catalog. So there is a easy API, a lot of dashboards that are available to see exactly what is inside that Puppet DB. And you can also have exported resources, like on node A, I want to monitor that daemon, but I will say on that daemon, okay, I will export a Nikinga resource or a Nagios resource, and that will be collected and applied on the monitoring host. Then you will deploy your Puppet tree. How do you do that? So you have a Puppet tree package, you install the Jira files, you might put it in Git or maybe do other packages, and then you do a Puppet apply to have a basic servers. And you only get a basic server just to run the next agent that will set up the different things on your server. So the goal is to have a first one that will just set the minimum. You will need to look at 2 alternative Puppet modules because Puppet Labs do not provide a Puppet module to set up Puppet. But you also have tools that can help you with that, like KFO, that will apply a bunch of Puppet modules into one packages. This is used by the foreman to give an installer that you can just run like foreman install, and then you get Puppet running behind the scenes. You need to think about security. Like if you have a Puppet agent, you can have a daemon running, but it's probably better to launch it with cron because it runs as root, and some customers have troubles with things that run as root. With a cron job, at least you know when it will run, and you know you will reduce the time frame when it is vulnerable, if there is a vulnerability. The master it runs as a Puppet user, but it should be on a separated host. So if there is someone that can access one of your application hosts, it should not be able to access the master. Otherwise, you will get more and more problems, and you just get root on all the machines basically. So you should put a reverse proxy over in front of the Puppet server, Puppet master. That's best practice for Java applications, and I think it makes sense. So you just make the server listen to the loopback address, and then you put a reverse proxy in front of it. You should not use, so with Puppet you have a SSL certificate that needs to be signed, and then you should not use the auto-sign feature because then anyone with the same host name could just sign his own certificate. So this is something you should just don't do that. Don't use that feature of Puppet. You can use the external CA if customers has one, and you should isolate the service from the application. I mean, the Puppet master should not run on the same server as your application for security reasons. And you have Puppet DB, but you need to look at it from your monitoring tool. So that's important to know that if something is wrong, you should be noticed. But some customers already have a Puppet master. So what you need to do is to work on a separated Puppet environment. And you should put your Jira data in a subdirectory also, so there is no conflict possible. If you have custom functions, you can have custom function written in Ruby in Puppet. you should add a prefix to them, because Puppet does not provide isolation for the functions between the different environments. So if you have a function called maker hash and the client as the same function, then you will need to change your function to have a different name so that they will not collide. And you should be careful with exported resources, because if there is an existing Puppet and you collect the resources, then you will just get all the resources of the customers as well, and this will just not be okay. So the conclusions is that when you ship your application with Puppet code, everyone gets benefits. So the developer, the QA, the testers, everyone. But you need to think how you release your application. You need to think how you deploy your operating system. And Puppet is part of your product. So your Puppet code is part of your product. You should not see that as a separated box. No, it's fully part of your product. So you will be able to set up your product easily, both internally and externally. You will get consistent deployment at several customers. So if you have 100 customers, they will all have the same setup. No matter who did actually install it. You will know upfront what should be deployed on that host, because you can inspect a catalog just by knowing the YARA files. And you get a clear view of the infrastructure, so you know which node contains which service, and so you will reduce the size of the different procedures. But yeah, this is a big cultural changes, because people will just say, yeah, but in the past we used to modify that file in Norway, and now it does not work, or yeah, you know, the current installer still works, let's still use that, because then we can work around the problems that we did not tell you. And so that is a big change for people to understand that now the way the enterprise is working is with automation, and people don't get it yet in other industry than the IT industry. When you have a resource, you should also take care that if there is an update and you don't use that resource, you will also remove it. Otherwise, you will have a bunch of old artifacts that are still installed on the server and that will not be removed on update. Then the data, in this case, it's you will need to find a way also to do the database migrations and stuff like that. There are tools to do that, but you have to find the tools that will just work for you. And then you need to teach the customer that, yes, you need to keep your infrastructure up to date. Now I have given a tool called Puppet, and you can use that to be sure that if you update Apache, you will not break your configuration. So please update Apache if there is a problem. And so that's also a challenge, a work that needs to be done to educate the customers that it is not black boxes, that they need to take care of that. It's like a Pandora box. So if you ship your application with Puppet code, then you can start thinking about, no, I will ship my monitoring system also, because with Puppet is just adding one module. You can enforce the best practices, like I will not permit to connect to SSH to that machine with a password, for example. So it's really the start for an improvement into the infrastructure on which you will connect to. You can then do the repository management on your side, so that you will ensure that customer will always be able to do updates and that it will always work. So, and then you can bring your own tools. So it's a bit like monitoring. So if you want to use a monitoring solution different than the one that the customer is using, you can still, by Puppet, play around with that and just install your small agent. And it will not cost you a lot of time to just add a small daemon, but it would cost you more time if you are just installing it using a bash script, because then you will need to think, okay, how can I actually do that? And so with Puppet, it's really a Pandora box that you will just be able to improve greatly the way you distribute your software. Thank you. Any questions?
So you mentioned Puppet with a master and an agent, and you said don't use auto-assign. So how are you solving the problem of allowing your customers to, when you run the agent, to sign the certificate for the agent on the master?
Well, the cleaner way might be to use an external CA. Then the agent is then providing the SSL certificates, and when you install the Puppet agent, then you just put the certificate at the right place before you actually use it. So that's an option. Or you can use autosign, but then with a defined list of hosts, and when the cluster is done, you just remove that file. That's also a possibility if you want to do that quickly. But I prefer to use an external CA, so I know that if there is something that needs to be signed, I can just sign it. You have project like the Foreman that will just use that autosign file, but they will just remove the node just after it is installed. Using an external CA also allows you to have several Puppet masters without having the same certificate, I think.
More questions? Yes. So you mentioned, so as I understand, what you're suggesting is correct me if I'm wrong, you're suggesting that you encourage application developers to maintain their own Puppet manifest for deploying the application they're developing. Is that right?
Yes.
So why? So you then suggested that they package up their manifests as a package. I assume like an RPM or something. Why not just use why package? Why not just to pull the manifest down using Git or something?
Sorry.
Why just clone the manifest?
Yeah, basically the packages should be done by your CI system like Jenkins or something like that, and it's part of your build system. Actually, in the real world, you will not be able to make a nice RPM of your application, probably because you use an old way of building the packages, but you should end up with the CI like Jenkins that will do it at each push. It will be able to provide a package, for example. The way we work is really when you push, you should run some fast tests so that you can get a quick feedback on your code. Then you can package the application and then do integration tests on your platform. And you can do that also with your Puppet code. So when there is a Git push, then you can trigger a rebuild on the host in your data center and set up the full Puppet stack on that node. But then you need to think how you actually deploy new host and to be able to rebuild a host in like 2 or 3 minutes, or to have just pending host that needs to that way to be set it up. It's also possible. Okay, thank you for your attention.